Okay, we are going to talk about standard reduction potentials, okay, also kind of known as standard cell potentials. All right, so as a recap in the last video, this is our illustration of a galvanic cell. Okay, this is a galvanic cell. Okay. Again, as illustrated, you will have your different solutions, and you will know what you have, or it will be stated to you in a question. So one total compartment is the anoid. The second compartment, all of it, the entire beaker and everything that's going on, is known as the cathode. Real fast, the anoid is going to be pushing or forcing electrons, and in this case it is 2 electrons, to our power source, leading to 2 electrons being pulled into the cathode, and this is exactly what's going on. Okay? All right, so now how do we calculate standard reduction potentials? Okay, standard reduction potentials. In your book on page, this is the older book, I apologize, Eli and Caitlin. Okay, so in your older book on page 843, table 17.1, this is what I was referring to. This is the chart. So again, you also have this in your PowerPoint that I printed off for you, but this is where we're going to look. So in the last video I didn't have this available, but now I do. All right, so let's go ahead and play with this galvanic cell, and let's actually do the calculation so you guys can understand why this is an anoid and why the other compartment is a cathode. All right, so writing this out, I have zinc solid plus copper 2 aqueous yields zinc 2 plus aqueous plus copper solid. Okay, let's do the half reaction. You have zinc, and that is going to be elemental, so that has a 0 charge. And then you have zinc with a 2 plus on the other side. There is a difference of 2 electrons, so on the most positive side, we are going to add 2 electrons. You know that this is a Leo because we are losing electrons, and this will in fact be an anoid. All right, now let's take care of our coppers. We have copper with a 2 plus. That's an aqueous solution, yields to copper solid. Solid is elemental. You have a 2 plus on this side, so on the most positive side you're going to write the difference, which is 2 electrons. All right, this is gaining electrons, so this is the red reduction cathode. Okay, red cat. Reduction is the cathode. All right, so in order to calculate our standard reduction potentials, again, let's get fancy with the E. You will have the cell. Let's go ahead and do zinc yields to zinc, that's a yield sign, to 2 plus. And we are going to add that to copper. 2 plus yields copper. Okay. All right. So on the standard reduction potentials, and these are common for most, what you can do is, so I'm looking over here, we are going to look for zinc, and as I transfer over here, you will see zinc with a plus 2 electrons. That is exactly what we're looking for. And again, like I said, don't be surprised if this is a negative. The thing is, we did not have to balance, and I will go ahead and balance for you so that we are going to consider that as absolute value, 0.76. All right, let's look at copper 2. Copper 2 is the 0.34. So if I look on my chart that you guys do not have to memorize, but it will help you to at least figure out where you're looking at in the numbers, you will notice it is a 0.34, and there's our standard potential, and the unit is measured in volts. So I'm going to write that back over here. 34, simple addition, simple addition, bam, that is our answer. Okay, So for that half reaction, now let's